Hi guys, my name is Terry. In this video, I'm going to go through the Additional Mathematics SPM trial paper for the year 2021 for Kedah paper 2. Let's get started with question number 1. So here we have a diagram that shows length of arc of swing of a simple pendulum that is released to swing freely. So you're supposed to find the length of arc of the 10th swing. So you can see the length of the first arc is 18, second is 14.4, third is 11.52. So it reduces, right? Now we have to decide whether this forms an arithmetic progression or a geometric progression. Yeah. So and you are supposed to find the length of arc of the 10th swing. Now you can see that is quite obvious it's going to be a geometric, not an arithmetic. Yeah. Usually for all this length of swing, it is going to be a geometric. Yeah, but let's just test it out. If you try to use arithmetic, we take T2 minus T1, the difference is negative 3.6, and obviously you're not going to get negative 3.6 if I take T3 minus T2. Yeah, you can see this 11.52 minus 14.4. It doesn't give us the same common difference, right? So for geometric, we have to show that it has a we need to show that it is increasing or decreasing at the constant rate. We call it the common ratio. So take 14.4, you divide by 18, you can see that your common ratio is 0.8. And we validate by taking 11.52 divide by 14.4. Yep, you should get 0.8. So the first part is, of course, to find out or identify your first term and your common ratio. My first term is 18. Yeah, my common ratio is 14.4 divided by 18, which is 0.8. So we know this is geometric progression. So the geometric progression, the value of the n term can be found by using Tn equals to A, R, n minus 1. So you're finding the length of arc of the 10th swing. So we use A, which is 18, R, 0.8, n minus 1. If your n is 10, n minus 1 will give us 9. So let's use 18 times 0.8 to the power of 9. All right, I got 2.416. 2.416. Give your answer correct to 4 significant figure will do. I don't have to use 5 or 6. Okay, 4 SF is good enough. All right, next. On which swing the length of the arc is first less than 2 cm? So we know it's going to reduce. Yeah, for the subsequent swing, the length of arc will be smaller and smaller. At one point, the length will be less than 2 cm. So let's just use the formula again. A, R is 0.8, n minus 1 less than 2. Okay, to solve this, we have to use the logarithm, but first we have to divide this. Remember, 18, you cannot multiply 0.8, right? They don't have the same power. You have to divide it instead, as in, we take 2 divided by 18, and 2 divide 18 gives us 1/9, right? And we cannot solve this directly because we know 1/9 cannot be written as 0.8 power something, right? 0.8 power 1 is 0.8, 0.8 power 2, 0.64, and so on, 0.513, 512 for power 3. You will never get 1/9. So in this situation, we'll introduce logarithm on both sides of the equation, and I'm going to bring the power n minus 1 in front. All right. And at this stage, we can just use a calculator and divide. Okay. All right. This is log 1/9. You got to divide with log 0.8, right? And whatever I get here, I need to plus 1, right? Plus 1. If not, you can just do one extra step, right? 9.847. 9.847. Okay. However, this is 9.847. However, there's one thing you need to take note. Whenever you times and divide with negative number, the inequality symbol must change. This is still n minus 1 though, but this inequality has to change because log 0.8 is a negative number, right? If you don't believe me, you just type it up because we can't see actually from here. We divide directly, we won't be able to see it, and some students will forget to change the symbol as a result. See, log 0.8 is a negative number. In fact, if you take any logarithm of a number between 0 and 1, let's say your y value is between 0 and 1. When you take logarithm of any number between 0 and 1, it's always going to be negative. And it's negative, the symbol here has to change. Remember to change the symbol here. Now, after you change the symbol, we know we can bring this n minus 1, the minus 1 to the right. So you will get 10.847 and should be what? 11, right? For that means on the 11th swing, we will have the length that is first less than 2 cm. All right, I've got my part A, I've got my part B. The last part, we want to find the total swing distance, total distance travel by the swing before it stops. All right, so by the pendulum before it stops. So we know we have to use sum to infinity because this number is going to go on and on and on. Although it's going to be smaller, but there is still a distance travel, right? So we just have to use sum to infinity. Your sum to infinity is given by A divided by 1 minus R. So in this case, the total distance will be your A, which is 18 divide 1 minus R. R is 0.8. So it's basically 18 divide 0.2. You can just use your calculator, not sure. 18 over 1 minus 0.8. My answer is 90. So the total distance traveled before it stopped is 90 cm. Okay, question number 2. This is from coordinate geometry. This is actually a old past year question, 1990 something. All right, here we have a diagram that shows rectangle TUVW on the Cartesian plane. So you're supposed to express B in terms of cube. Now, it says it's a rectangle. Rectangle means all this side, four sides must be 90 degree, right? So the first thing to come to your mind when you see 90 degree, we know that these two sides, the gradient, the line, let's say TUV, the gradient multiplied together must be -1. Whenever two lines are perpendicular, the gradient multiplied together equals -1. So we're supposed to express B in terms of Q. So that means I have to use this information, my coordinate point V. So I think we can use gradient UT, or you can say TU, multiply with gradient UV. The result must be -1. Okay, for UT, to find the gradient, we use y2 minus y1, 6 minus 4, divide x2 minus x1, 5 minus 0. Now, this is your gradient UT. As for gradient UV, I like to use Q first. It's easier. Q minus 6 divide B minus 5. Right? But if you write 6 minus Q divide 5 minus B is also fine. You will get the same answer. Okay, now the next thing is I need to simplify this. Okay, to simplify this will be 2 over 5. All right, this will be Q minus 6 over B minus 5. The result is -1. Now remember, I want to find B in terms of Q. So I need to make B as a subject. So I'll multiply B up. Now some people prefer to multiply the 5 inside first. You can, right? You can multiply inside first, up to you. I think I'll multiply inside. This is 2Q minus 12. I multiply 5 inside and I bring it over. So it's a -5B. 5 times -5 is -25. I multiply over is +25. And I want to make B as a subject, right? So I will bring the 5B to the left. I bring everything else to the right. 5B is now 25 plus 12 is 37. U minus 2Q. All right. And from here, we divide by 5. B is 37 minus 2Q over 5. So this is my B in terms of Q. All right. I solved the first part. Second part, show that the area of triangle is given by this B minus 5 over 2Q plus 10. Okay, area triangle TUV, as you can see, is actually this triangle here. All right, maybe I just highlight for you. This is a triangle TUV. All right, so I'm supposed to find this area. Now, remember, when you use formula for area, we call it the half x1, y1, x2, y2, x3, y3. Repeat the first point. Now, when you use this, they call it a shoestring method, some people, or array method. All right. When you use this formula, remember when you choose clockwise direction is always negative. Anti-clockwise is always positive. So for me, I would choose anti-clockwise straight away because otherwise my area will be negative later, right? So normally we say if we get negative, we say we modulus it, take it as positive because area cannot be negative. But to avoid complication, we just take anti-clockwise. Yeah. When your diagram is given, we just do anti-clockwise. When a diagram is not given, we don't know, right? We don't know whether which side is clockwise or anti-clockwise. That is fine. So here your area is half. Let's say I start with T, right? I don't want to do TUV, I do TVU, anti-clockwise. T is 0, 4, V is BQ, U is 5, 6. Repeat the first point. Now let's multiply downwards. This will be 0. This will be 6B. This will be 20. This will be 4B. This will be 5Q. All right. 5Q. There you go. That is your expression. Okay, actually, we can just put this as a bracket. Now, let's just finish this up. All right. We will have to simplify further. This will be 6 minus 4, which is 2. I'll write minus 5b first, minus 5q first, because the 10 is at the back. 20, I write later. Multiply the half inside. B minus 5 over 2q plus 10. There you go. That's your answer. Area is given as this. B minus 5 to q plus 10. Okay, next part. It is given that the area of the triangle, area of the quadrilateral rectangle TUVW is 58. Find the coordinate of V. Now, the coordinate of V means you're finding P and Q. So first of all, I know if the whole thing is 58. This is only half of it, right? The whole thing is 58. So I think we can just take this area, multiply by 2. So this area, if you times 2, is P minus 5 over 2Q plus 10. This area is now 58. All right. So multiply inside. 2P minus 5Q plus 20 is 58. 2P minus 5Q, bring the 20 over. 58 minus 20 is 38. So this is your second equation. Call this first equation because we need to solve for P and Q. So we have two equations now with two variable or two unknown, P and Q. So since P is already written as a subject, for the first one, I sub 1 in 2. Okay, my P is 37 minus 2Q over 5. U minus 5Q. This is 38. Now let's multiply everybody by 5. Yeah, just to get rid of fraction. At the same time, I multiply this inside 1 by 1. We know 2 times 37 is 60, 74. This is 4Q. Sounds like a bad word. 5 times 5 is 25Q. And this 5 times 38 is 70. Wait, divide by 5 to 190, right? 190. Okay, so I can simplify this, right? Well, let's put this together. 74 minus 29Q is 190. All right, bring the 74 over. Minus 29Q, you minus 74, you should get 116. So Q is 116 divided 29. Can't do mentally, use calculator, right? I got 4. Yeah, negative 4. There is a negative here. Q is negative 4. Okay, next I want to find P, right? So we sub inside equation 1. My P is now 37 minus 2 minus 4 over 5. So 37 minus 2 minus 4 is 8. 37 plus 8 is 45. 45 divided by 5. P is 9. So I've got the coordinate. Yeah, we just write the coordinate of point V is now 9, negative 4. There you go. That's your answer. Okay, moving on to question 3. This is from Trigonometry, Form 5, Chapter 6. Okay, the first part. Show that tangent square minus cotangent square is secant square minus cosecant square. So the first part is the proving question, I think I'll start here. Now, you can choose to start from left or from the right. So, but first thing first, we know this is involving the basic identity formula. Now, basic identity have three formula. The first one is cos square. Let me write in x, plus sine square equals to 1. Second one, all these three formula are given, but for me, I just mentally divide. Cos square divided cos square is 1. Cos sine square divided by cos square is tangent square. 1 divided by cos is secant square, right? So I know I have secant square given as a subject. So perhaps you should start from here because we can replace secant square with 1 plus tangent square. At the same time, when you take a cos here, you divide by sine. Cos divided sine is cotangent. Sine divided sine is 1. 1 divided sine is cosecant. And I notice that cosecant here is also written as a subject. So we can actually replace secant square and cosecant square with these two information, 1 plus tangent and cotangent square plus 1. So let's start with the right-hand side, all right? My secant square is 1 plus tangent square x. My cosecant square is now cotangent square x plus 1. So let's expand the bracket. 1 plus tangent square minus cotangent square minus 1. 1 minus 1 is 0. Tangent square, you're left with tangent square minus cotangent square, which is exactly as my left-hand side. Okay? All right, second part. Plot the graph. Yeah, plot the graph for y equals to 2 cos pi over 2x for x between 0 and pi, 0 and 3. Okay, one thing I want to say in SPM, they rarely ask any question, if not never. Since last 20 over years, they never ask about plotting graph. It's usually sketching graph. Now, the difference in plotting and sketching is that sketching, we sketch on the paper, on the answer paper, whatever. But plotting, we have to use a graph, and plotting, we need table values. So here, since they say plot, so I would just build the table values here. All right. My table value is a bit ugly. Let me just try to fit everything inside. Now we have to use the scale. Now read the question. The question says the scale 2 cm to 0.5 unit. So we use x and y 2 cm to 0.5 now. And the largest is 3. That means we start from 0. We end at 3. So 0, 0.5, next 1, 1.5, 2, 2.5, and the largest is 3. Okay. Now, the good news is we can actually use your calculator to generate this. If you're using this calculator, right, we can actually generate table values. We don't even have to count. We press mode, go to 7 for table, right? Your function is 2 cos. But one thing to take note, that this is pi over 2x. The angle is in radian. So you want to change your calculator to radian mode. You can see the calculator by default, there's a D here, is in degree. Press shift mode to number 4 radian, right? Then we type pi over 2, and your angle x is alpha x, close bracket, right? Then you press equals. All right, ignore the second function. We only need 1 gx, let it be. This one start with 0 and with 3, and then the step is 0.5. Step means the difference between each values of x, okay? It increased by 0.5 following the scale given 2 cm to 0.5 on the x-axis. Okay, so the first point is 2. Next one is 1.4, 1.41. Now, again, if you, we can't read 1.41. One thing what you can do, if you're lazy to round off mentally, we can fix the decimal point to 2 decimal point. Okay, there you go. The calculator will round off for me 1.41. So the first one is 2, second one is 1.41, third one is 0. 2, 1.41, third one is 0. Then we keep going. Next one is negative 1.41 to negative 2 and negative 1.41. Negative 1.41, negative 2, negative 1.41. Yeah, it goes negative and come back up. Okay, last one is 0. Now, actually, you don't need this table. Yeah, if you understand how to plot the graph, you don't need to point by point, because we know that if you're given y equals to a cos bx plus c. The b here is represent number of complete cycle from 0 to 2 pi. And we also know the idea of period. The period is 2 pi divided by b. In this case is pi over 2, right? Can you see? Pi over 2. So what is your b? B is, if you cross multiply, right? My b is 4. That means you will complete one cycle at 4. So meaning when you draw a cos graph like this, 4 will be here, right? So we can see a 4 cos we can divide evenly. Right? This is 2, this one is 1, this is 3. So we know we have to draw up to here only, right? We don't need to draw more than that. Another thing is that the number in front, your A, represent your amplitude. In this case, your amplitude is 2, so maximum 2 minus 2. So we don't really need the table, right? We can actually draw it without the table. But anyway, since they are given, I will just draw here. And they say the scale is 0.5. So 2 means I need 4. I need 4 vertically, right here. All right. So I actually cut the graph paper, make it smaller because we don't need such a big graph. We don't need such a big graph paper to draw this. So that's why I trim it. So up to here. In fact, your horizontal also, you don't need such a long graph. You see, I only need 6 boxes. Yeah, but I just extend until 8. Okay, so we only need 6. It's a bit hard for me to move it. There you go, until 6. 6 boxes. Okay, so now this will be 2 same 0.5. So this 0.5, 1.0, 1.5, 2.0. This is your y. This is 0 minus 0.5 minus 1.0 minus 1.5, 2.0. Okay, so this will be 0.5, 1.0, 1.5, 2.0, 2.5, 3.0. Okay, so this is your x. All right, my graph. Now I have to plot. First point, of course, 0, 2 is here. 0.5, 1.41. 1.4 is approximately here. Now we can't even read 1.41, so I'll just plot 1.4. Next, 1 and 0. All right, 1.5 and negative 1.41. So it's here. Now, I hope you know what, one small box is 0.05, 2 small boxes is 0.1. So that's why it's over here. And then we go down to here. All right, to here. Come back up. And then ends here. Okay, now this will be a bit hard to draw. You need to use a thicker pencil. Please use 2B pencil. Use 2B pencil. Yeah, it will help to hide the ugliness. It goes down all the way. Okay. Oh, look at this is very ugly. Negative 1.1, 1.4. Oh, sorry, I plotted my 2 wrongly. Oh, my 2 is below here. Sorry. Yeah, I plotted my 2 wrongly. Okay, my 2 is supposed to be underneath here. All right. So let me just go all the way down. Very ugly. Curve. Okay, this part had to change. Okay. Yep, my graph is done. All right. So I still need to use the result from the first part to solve the second part. Okay. So there's a hint from the graph, find the value of x that satisfies this equation. All right. So starting from here, let me start off. From cos pi over 2x, I'm going to bring the 1 over 4 to the right. So it's negative 1 over 4. Now remember, you do rearrange the equation such that one side equals to the graph here, the cos, this graph here, to cos pi of 2x. So what I'm short of is a 2 on the left. So I multiply by 2 on the left, and I multiply by 2 on the right. So 2 times negative 1/4 is negative half. Negative half is 0.5. So here I just use a slightly different color here. Okay, I think better use the same color. All right, I will draw a horizontal line. Y equals negative half is a horizontal line. Now you notice it intersect the graph. Yeah, both graphs actually intersect. Yeah, at 2 points. So this line is not very dark. So I make it darker. Yeah, dark line, can see. Okay, so the point of intersection in this case is here 1.1. This is 1. Looks like 1.15. Okay, I may have to zoom in a bit, hard to see. Yeah, it looks like 1.15. Yeah. Now the accuracy that you have is up to half the smallest box. This is 1.1. 1.1 is over here, 1.15. Yeah, this is 1.15. Okay, second one is also 3 boxes from here. So it's 2.85. Yeah. You can't get more accurate answer than that because this is, unless it's you are taking half of the smallest one, right? I think it's okay. We just take 1.15, 1.8, 1.15, 2.85. There you go. From here, we say that, okay, let me just move this back. Okay. From here, we say from the graph, the solution to this equation is the intersection, because you're drawing y equals negative half. Yeah. You're intersecting it with the original graph. So from the graph, the solution, we are finding this exact solution. Yeah, so it's not the, normally when you sketch a graph, we find number of solution. When you draw the graph, we find the solution to the equation. Your solution will be x equals to 1.15 and 2.85. All right. Okay, question number 4. This is probability distribution, chapter 5 from 5. Okay, the first part is a binomial distribution. In fact, both are binomial actually. First part, class 5 RZ has an M number of pupils consists of boys and girls. Mu equals to 9, sigma is this, find the value of M. Okay, so here's the, I think there's a flaw in the question is that if your mu is 9, they didn't mention mu represent what? Girls, boys, mean they have M student, yes, right, consisting of boy and girl. So they must mention actually mean number of girls or mean number of boys, right? I mean, that means X represent number of boys, number of girls. On average, if I choose N student randomly, then how many boys do I have? All right. What is my average number of boys, number of girls? Okay. Anyway, we'll just do this. Your mean is 9. So mean is given by MP. In this case, M. This is 9. Okay. This is standard deviation. Standard deviation is 3/70 over 10. And standard deviation is square root of NPQ. In this case, MPQ. So 3/70 over 10. So what I need 70 here is to square both sides, MPQ. When I square this, right? Now nowadays you don't need to use brain to count. We can just use a calculator, right? It looks like this. This is 3. Okay, maybe I put 10 below. Then this is square root 70. Yeah. Okay, whatever I get, I square it. Yeah, my answer is 63 over 10, right? 63 over 10. Yeah, you want to do mentally also can. 3 squared is 9. Square root 70 squared is 70. 10 squared is 100. You cancel the 0, 63 over 10. Okay, now let's take the second equation here. And I divide by the first equation. So MPQ divided by MP is now 63 over 10 divided by 9. Now notice you can cancel M and M, P and P. I'm left with Q, right? In fact, 63 I can cancel with 9. I'm left with 7, right? So here I got Q equals to 7 over 10 or 0.7. So now that I got my Q value, I need to find my P value. before I can find M. So we know the relationship between P and Q. See, P stands for probability of success, Q is probability of failure. If your Q is 0.7, your P should be 1 minus 0.7, 0.3. But I haven't answered the question yet. The question wants to find M. So we need to find P before we can find M. So we sub inside equation number 1. My M times 0.3 is 9. 9 divided by 0.3, answer is 30. Yeah, you're not sure, use a calculator. 9 divided by 0.3, there you go, 30. Okay, I better change this decimal. 6. I'll just go to shift clear all. Okay, now next. Hence, if 10 students from the class 5 RSE are randomly selected, find the probability for girls, 4 students are girls. So here's the thing you need to know. Okay, in fact, there is one flaw in the question. When we say, I hope you understand the idea of binomial distribution. So when you choose student from binomial, it's like boy, girl, boy, girl, boy, girl. I choose 1, I choose 2. Now, the thing is, we cannot, guys, we cannot choose without replacement. Remember, binomial has 4 criteria. It's fixed number of trials, 2 possible outcome, boy or girl. Third one is independent, and last one is constant probability. That means you choose a boy, you need to put it back. Yeah, you put back, and there's a chance for you to choose the same boy again, right? Otherwise, the probability will change. The probability is not constant, right? So here's the thing: you can assume, right, that you can choose the same person again. Now, the problem is, what is X? Is it boy or is it girl? The question didn't clearly state this. So once I refer to the marking scheme, they are actually saying is referring to girls, right? So maybe they should have said that this is mean number of girls is 9. And the standard deviation for number of girls is this. So here X is girls. X referring to girls. Okay, let me do here. So your X is, you can write the whole definition, discrete random variable representing number of girls. Okay, this is number of girls selected. So now I'm sure you've seen this, right? If you don't want to write this, is okay. This one simply means what? X has a binomial distribution where N is now 30, and 10. We are choosing 10 students now. All right. And what is your P, probability of success? You're choosing girl. Girl is 0.3, right? Because P here is 0.3. Okay, so you want exactly 4 girls, right? So we can say Px equals to 4. Now use the formula 10C4 P 0.3 power 4 Q 0.7 power 10 minus 4, which is 6. Okay, if you can't remember the formula is given in exam, is NCR P power R Q power N minus R. This formula is given. Okay, so you can use a calculator, type in 1 by 1. I want to show you how to use this calculator because this calculator is so good, right? I call it a Bugatti. I call this a Ferrari. This is a Bugatti. And the old calculator is a Toyota. It's reliable, but it's just not as good. Yeah, as fast, as powerful as this. Anyway, now let's do this table 9. I need to reset my decimal. All right. Okay, so you press mode. You go to this one, number 7 here for distribution. You go to number 4 for binomial distribution. Now you go to number 2 for variable, right? So you want your X to be 4. You want your N to be 10. Your P to be 0.3. 0.3 here, right? And then, there you go. Your probability is 0.2001. Yeah, so it saves you time to type the calculator. If you type this, it's a lot more work to type with a bracket and things like that. All right, but it's up to you. If you have the calculator, you can use this function. Yeah, if you don't have, it's okay. Just type in manually on the normal calculator. All right, now the next part, they say at least 9 students are male. So here's the thing, you need to understand your X will have changed. Your definition will have changed. So X is now a discrete random variable, DRV, representing number of boys or male. We should normally say girls, boys, male, female, but it's okay. I just say boys, okay? The question say male. All right. So your probability is now no longer 0.3, is 0.7, right? You can only have boy or girl. Okay, cannot have anything in between, okay? Now, anyway, your X, you want at least 9 male. At least 9 male is greater equals 9. So greater equals 9 means we are talking about 9 and 10 because your maximum is 10. So here we can use 10 C9, P is 0.7, power 9, Q is 0.3, power 1, right? Then you add with 10 C10, 0.7 power 10, 0.30 power 1, power 0.3 power 0. Okay, you just add them up, get the answer. Now, again, I want to show you how to use this calculator. There are two ways to do it. Number one, we can use binomial PD again if you want. All right. But you need to go to the list. Why do I use list? Because I have two values to add up. The first one is 9, second one is 10. So I put a 9 and I put a 10. There you go. And I press equals, and it's still 10. P is now 0.7. There you go. I got these two values. So what I need to do is basically add them up. Okay, this is the advantage of having two calculators. 0.1 to 1. You can write 1 to 106 if you want. Then you add more decimal point. Next one is 0.0 to 8248. Yeah, there's too many decimal point actually. Maybe I just do 5. Okay, there you go. 1493. Yeah, 0.1493. 0.1493. Okay, now there's another way to do this because this calculator has what we call cumulative density function for binomial. You press mode, you press 7. All right, you go press this down. Binomial CD, press 1. Okay, we go to 2 for variable. Now, binomial CD, the word CD means cumulative. Cumulative means if I say my X value is 2, means 0, 1, 2, add together. If my X is 5, means 0, 1, 2, 3, 4, 5. Now, here's the thing. I want 9 onwards. I don't want 0 to 8. Yeah, I don't want 0 to 8. I want 9 onwards. So I'll press 8 here. All right, everything else being the same, I press equals. This is 0.85069. Okay, and this is 8 and less. That means 0 to 8. I want 9 and above. So I take 1 minus 0.8507. There you go. I got the same answer. 1493. So it's up to you. Yeah, you want to use this, you want to use the other function, or even you want to use a silver calculator that's calculate directly is also fine. All right. Okay, question number 5. So this is a Form 5 Chapter 2 differentiation question. We're supposed to find the value of A and B so that this straight line becomes a tangent to this curve at point x equals to 3. So understand this, when the line is a tangent, the line touches the curve at one point, and this x value is 3. Now, we can start from the straight line, we can start from the curve. The thing is, we need to know what is the gradient of this line. Yeah, starting from this line, I think we change this to y equals mx plus c, right? I rewrite here 3y equals minus 2x plus a. Your y is minus 2 over 3x plus a over 3. Okay, so what is the gradient of this line? The gradient of this line is your gradient tangent, right? Negative 2 over 3. Now, how about your this equation here? We're supposed to differentiate. Let me write here dy dx. When I differentiate this, bring the power 2 in front, copy b, copy x. And we know at this point, your gradient dy dx is negative 2 over 3. And it happens when x is 3. So we put 3 inside. Okay, you divide it. You can write extra step 6b is minus 203. You divide it, you cancel out. In fact, I can actually prefer to cancel this and this. 3, you multiply down, right? So my B is negative 3 times 3, 1/9. Yeah. Okay, but how do you find the value of A? Now, before you find the value of A, we need to find your y coordinate when your x is 3. So going back to this equation here, my y is now b, negative 1/9. My x is now 3. You square it. My y value is negative 1. If my y value is negative 1, we can sub inside this equation here. Because I know my x is 3. My y is negative 1. I sub inside here. I find my a. My a is 2 times 3 plus 3 times negative 1. My a value is just 3. Okay, moving on to part B. It is given that when you differentiate this, you get 16x power 4 minus 1. They say by using tangent sketching method, yeah, determine the stationary point where x is 1/4. Okay, so here's the thing. We know that this is your curve. This is your gradient function. So when we say tangent sketching method, we are actually, drawing the smiley Korean face method, we call it, right? We want to see the changes in the gradient of the tangent. All right. Now, what is the value of x, right? The value of x is half here at the curve, at what we call that when x is half. This is x less than half. This is x more than half. All right. So then we look at the value of dy dx. So we can actually use our calculator. We key in this function, the gradient function, 16x power 4 minus 1. 16x power 4 minus 1. We calculate, pick a number. So let's say you put half. It is going to be, 0, right? Now pick another number, let's say slightly less than half. We take a number slightly less than half. Slightly less than half could be, we can put 0. What happens is you get negative 1. Now, you don't have to write down exactly what's the value, right? Because you can pick any random number as long as this is less than half. Just now, we know this is at half is 0. At a value less than half is negative 1, so it's less than 0. Take a value more than half. Maybe I take 1. It is going to be more than 0. In this case, 15, right? Okay, then we know we can sketch your dy dx. Yeah, the sketch with dy dx means we want to look at the gradient of tangent. If it's less than 0, negative gradient is like this, going down. 0 gradient, horizontal. Positive gradient, going up. Then we write sketch of y or the curve. If the gradient actually goes down, horizontal, up, then the curve should go down and up. So we know the type of turning point, yeah, the type of turning point is now a minimum point. Yeah, it is a minimum point. Okay, so B Roman 1, no problem. All right, second one. Hence, determine the coordinate of another stationary point. Well, this is your gradient function, 16x power 4. We know turning point happens when this is 0. We bring this over, x power 4 is 1/16. When you root this, I remember, when you square root quad root power 1/4 or even power 1/6, if it's even power, it can be positive, can be negative. Of course, when you root this, you can't see that. You put, let's say, shift root here with a 4, 1/16, you will get 1/2, right? All right. But remember, there is a plus minus involved, right? It's either positive or negative 1/2. But you want another stationary point. The first stationary point we know is x equals half. Yeah, it's already given here. So we know x cannot be half. We take x equals to negative half. Okay, but I still need to find my y value. let's sub inside here. This is your y. Your y is 16 over 5 negative 1 over 2 power 5 minus negative 1 over 2. Okay, calculator, 16 over 5. All right, negative 1 over 2, close bracket, power 5. Minus, I can just write plus 1 over 2. There you go. My answer is 205. Okay, so your coordinate of your stationary point is negative half 2 over 5. All right. Okay, question number 6. This is Form 4, Chapter 3, System of Equation. So here we are given that x, y, z equals to s, 4, and r is a solution to this simultaneous linear system of linear equation, we call it, right? So you're supposed to find the value of t and r, okay? T and r, we don't need to find s, right? Okay, so first of all, I will sub in the coordinate one by one into each equation. So when you sub S4 and R inside the first one, my X value is S, so we write 3S. My Y value is 4. My Z value is R. The result is 9. Now, notice here we have equation in terms of S and R. Yeah. So 3S minus R equals to this 8. I bring over is going to give us 1. Now, I don't know what to do with this, right? So at this stage, maybe I will leave it first. I'll give some space. The second equation I have is if I sub inside here, my X is now S, my Y is now 4. So T times 4, I'll write 4T minus 4T, and Z is now R. This is R sub inside. The result is 2. Now notice this second equation, you have all S4, ST and R, right? So I'll leave this. I think this one I don't want to do anything. I'll leave it out first. Now the third equation, when I sub in, my Y is now 4. So 3T times 4 minus 3Z. Z is now R. The result is 11. Okay, so what I can see from here is that the first equation has R, right? Second equation R, third has, all three has R. But the first equation you have S, another variable be S. The third equation you have T. So if I make S as a subject, I will be able to express S in terms of R. And I make T as a subject from the third equation, I'll be able to express T in terms of R. As I sub both inside equation number 2, I'll be getting rid of S and T. I'll be able to find R, right? So there are a lot of ways to do it, but I think this method is easier. We don't have to do a lot of work. I bring the R over, right? So you get R plus 1. Then I divide by 3 straight away, and I write S as a subject. Yeah. The reason why I make S as a subject, because I sub in, I'll get rid of S. And here you have 4 times 3. This is 12T. I bring the R over, 3R plus 11. T is 3R plus 11 over 12. So I got T as a subject. The more I sub both equation 1 and equation 3 inside equation 2, I will be able to get rid of S and T. So we got everything in terms of R. I can solve for R. Yeah. So I feel this method is easier, right? You sub 1 in 3, but you can use any other method. Yeah. If you want, sub 1 and 3 inside equation 2. My S is R plus 1 over 3. My T is 3R plus 11 over 12. And then I plus with 2R equals to 2. Yeah, notice everything is now in terms of R. So I cancel this. This is 3. And then I multiply everybody by 3. Okay, I multiply everybody by 3. I got R plus 1. But remember the negative you have to times in. So it's negative 3R minus 11. When you times with 3, this 2R must times 3, you get 6R. 2 times 3, you get 6. Okay, I've got everything in terms of R now. We take r minus 3r is minus 2r, minus 2r plus 6r is 4r, 1 minus 11 is minus 10, the result is 6, 4r is 16, r is 4. Okay, remember, I'm supposed to find t and r. I've got r already. I just have to sub inside equation 3, find my t value 3 times 4 plus 11 over 12. All right. Now, it's not a nice answer because 3 times 4 is 12. 12 plus 11 is now, 12 plus 11 is now 25. 23, sorry, 23 over 12. Okay, one good news, you can use your calculator to validate your answer, but you have to go back to this equation. So remember, your equation has STR. So for your first equation over here, let me just highlight for your first equation over here, STR, we go to mode, go to number 5 for equation, go to number 2, A, B, Y, Z, number 2. So my A is now 3, my RB is -1. The third one, this one I don't have T, STR. Okay, I don't have T, so my T is 0, my R is -1, and my D is now 9. Okay, so basically, we are taking this, this is your 3s plus 0 T, because it's STR, the last term is R, STR 0T minus 1R equals to 9. The second equation is 1S minus 4T plus 2R equals to 2. My third equation, this one no S, so I put a 0S minus is a plus 12T minus 3R equals 11. So let me just key in this in my calculator. The second one is 1, -4, and 2. Answer is 2. Third one is 0, 12, minus 3. I got last one is 11. Okay, so now your x is your s value, 11 over 3. We don't need s value. Your y, wait, did I just made a mistake here? Let me clarify, double check. 3, 0, -1. 3, 0, -1. D is 1. Okay, my first D is 1. Sorry, I wrote that wrongly. D is 1. This is 1, because here is 1. So this is 1. All right, my second one, 1. Second question, 1 minus 4 and 2. My number on the right, D is 2. Next one is 0, 12, minus 3, and 11. Okay, I think it's okay. 5 over 3. I hope this is correct. This one is y is your t value, 23 over 12. Yeah, correct. And my z is my r value, which is 4. Right. Okay, but of course, this is for you to double check your answer. Not, you can't do this in exam. You have to show all your working, the manual working, but just use your calculator to verify your answer. Right. Question number 7. This is from Indices and Surds. Indices, Surds, and Logarithm, actually involving Surds. All right. The first part, solve this equation. Okay, to solve equation in with a square root. Number 1, we bring the x to the right. So you have square root of 16 minus 8x is now 2 minus x. So what I need to do is to square both sides. I square the left and I square the right. Yeah, I square both sides of the equation. So 16 minus 8x. When I square this, I get 4 minus 4x plus x squared. I hope you know how to expand this mentally. Yeah, one by one. Okay, so let's solve for x. Bring everything to the right. Your x squared. Bring 8 to the right. So it's positive 8 minus 4. So it's 8x. 16 I bring to the right. 16 bring to the right. 4 minus 16, -12. I just rewrite everything on the left. Yeah, let it be 0. Now, notice we can factorize this, double bracket. Okay. Wait, this is 12, 6, and 6 and 4. I wrote this wrongly, sorry. 6 and 4. 8 minus 4 is 4, sorry. So this one should be 6 and 2 plus and minus. So x is now 2 or -6. Okay, but sometimes there's a problem with sometimes that this problem happens because some value, right, when you sub inside, all right, it doesn't satisfy the equation. Why? Because in the process of squaring both sides, right, when it comes to question like squaring both sides, you're actually creating additional answer. A classic example, if I give you x plus 1 equals to 3, right, the moment you square left and square right, you are actually getting x plus 1 squared equals to 9. So, and when you square root it, your answer is just -3 and +3. So actually creating additional answer out of thin air, right? So squaring both sides, you got to be careful because sometimes you may have an answer that is not valid. Yeah, is created by squaring both sides. So just to double check, we sub in, but make sure when you sub in, the left-hand side must satisfy the right-hand side. Yeah? If I put inside 2 plus square root 16 minus 8 times 2, right? This will be 2, right? Yeah, it's the same as right-hand side. So we know this answer is valid. And then if I put -6 inside, my left-hand side will be -6 plus square root 16 minus 8 times -6. That will be 64, right? Yeah, 16 plus 48, 64. Square root 64 is 8. So yes, it's still 2, it's still right-hand side. So both answers are valid, right? So in this case, no problem. Your answer, both are okay. So don't need to reject any answer. Okay. Now, A Roman 2. Given that 3 power x plus 1 plus 15 3 power x plus 3 power x plus 3 is now equals to this. Okay, so here I would have to break it up, right? Is equals to 3 power x plus k. So I think we can break it up to 3 power x times 3 power 1. Now remember laws of indices, a power m plus n is a power m times a power n. And the 15, I'll leave it 3 power x. And this one, I'll break it up to 3 power x times 3 power 3. Okay, here we have a common factor. My common factor is 3 power x. So we'll take out 3 power x, right? So I'm left with 3 here. I'm left with 15 here. And I'm left with 3 power 3. Yeah? Okay. Now, 3 power 3 is actually 27. So you can just do extra step, 18 plus 27. This will give us 45. Yeah, the problem is you want to express in this form. Can you see there's a x plus k there? That means you have another factor of 3. Yeah? So we know 45 can be written as 9 times 5. So what I'm going to do is I'm going to put a 5 in front. There's a 3 power x. 9 is 3 power 2. So I'm going to use this, but I'm going to combine back to 5 power x plus 2. Yeah, sorry, 5 times 3 power x plus 2. 5 times 3 power x plus 2. And there you go. I got my expression in this form. But we need to identify what's your m. My m is 5. My k is 2. My m plus k is just 5 plus 2, which is 7. Oh, this is very long. I'm out of space to do C, part B. Okay, so for part B, I'm gonna do over here. All right, the first thing I need to do, you're given 2 power s equals 3 power t equals 6 power u. Now, we need to break it up to 2 power t equals 6 power u. And another one is 3 power t equals 6 power u. Now, why do I do that? Because we know 2 times 3 is going to give us 6. So if I can express 2 in terms of 6 power base 6, like I know 2 is 6 power something, or 3 is 6 power something, then I can relate or link them up by using this equation. So now also remember, if I say x power 2 equals to y, when you bring over, this is y power 1 over 2. So if I say x power m equals to y, then x is y power 1 over m, right? So that's what I'm going to do here. I'm going to bring my t across. My 2 is now 6 power u over t. And my 3 is now 6 power u over t. All right. Okay. Yeah, so wait, did I write this wrongly? 2 power s, sorry. This is 2 power s. And that is 3 power t. So this is u over s. The other one is u over t. Okay, now, again, starting from here, 2 times 3 is 6. 6 power u over s. 6 power u over t, right, is now 6. 6 means 6 power 1. So when you multiply the number, we add the power. All right, so we compare them. U over s plus u over t is now 1. Okay, I need to make u as a subject. So I like to factorize the u. 1 over s, 1 over t. This is now 1. We put them together, cross multiply. So when you cross, yeah, we can say 1 times t, which is t. 1 times s, which is s. S times t, which is st. The result is 1. To find u, st goes up, t plus s go down. Now, whether you write t plus s, s plus t is the same. Yeah, your st over t plus s or st over s plus t. There you go. You got your u in terms of s and t. Okay, question number 8. This is question from vector for chapter 8. So diagram shows triangle POQ. Point A lies on OQ. Point B lies on PQ. Straight line PA intersects straight line OB at point C. Right? Now, you're supposed to express in terms of x and y vector PA and OB. Okay, so first of all, I think I'll just label everything first. You're given that OQ, OA is 5 to 3. That means the whole thing is 5. This is 3. This is 3. Whole thing is 5. So this is 2. So I'm going to write this as 5x, right? Since, 3x. Since OQ is 5x, so this is 3x. This is 2x. Okay, the ratio is 3 to 2. So I just remove this. Then you're given that OP is 4y. So we write 4y here. All right. And also PQ is 3 times of PB. PQ is the whole thing. The whole thing is 3. This is 1. So this is 2. So the ratio is 1 to 2. Okay, I'm supposed to express PA. So to go from B to A, I think we can just use the diagram here. Let me write my working over here. If you want to go from B to A, I can use this route. B to O, O to A. So it's minus 4y plus 3x. Yeah, minus 4y plus 3x. Now, you can rearrange it, but even if you don't rearrange it, it's fine. Yeah, normally we put the positive in front, we put the negative at the back, but if you don't do that, it's fine. Second part, how about vector OB? So to go from O to B, we can go from O to B, B to B. Now let's look at this. O to B, B to B, right? O to B, B to B. So O to B is just 4y. B to B is 1 over 3 of PQ, right? So we know PQ. PQ, 1 over 3 here. We can go from, for PQ, I can go B to O, O to Q. So it's minus 4y plus 5x. Yeah, minus 4y plus 5x. So, okay, minus 4y plus 5x. So when you multiply this, this will be 4 minus 4 over 3. Okay, maybe I do a bit slower here. 4y minus 4 over 3y, and then 5 over 3x. Let us write 5 over 3x in front. 4 times 3 is 12. 12 minus 4 is 8 over 3y. Yeah, 5 over 3x, 8 over 3y. Okay, first part we're done. Now, actually, I have a shortcut to find OB, but I know some people may not, how would I say, may not use this. It's similar to the ratio divisor line segment in coordinate geometry, the nx1 plus nx2 over n plus n. So my shortcut is this. We take 2 multiply with, because the ratio is 2, right? Multiply the opposite vector, 4y. 1 multiply opposite vector, 5x. Total ratio is 1 plus 2, which gives us 3. So this will be 8y plus 5x over 3. You can write over 3 over 3. Yeah, okay, this is 1 plus 2, sorry. The total ratio is 3. There you go. You got the same answer. It's so short, right? Yeah, but then if you want step by step, yeah, to get marks for exam, right, then this will be it, okay? All right. Second one, B. Given that OC is HOB, OC is H times of OB, BC is K times of BA, you're supposed to find better H and K. So first of all, I think it's better to find 2 versions of OC. Yeah, there are 2 ways you can go from O to C. One is the direct way, OC is HOB. Since I already got OB from above, 5 over 3x plus 8 over 3y. When you multiply inside 5 over 3 hx, this is 8 over 3 hy. I got my vector OC. Okay, the second version of OC will be this. I want to use BC, right? I want to go from O to P, followed by P to C. Now, O to P is 4y. P to C is K times of PA. All right. In fact, I got my PA already, right? My PA is 3x minus 4y. Okay, I need to expand. 4y you plus with 3kx minus 4ky. Put them together, 3kx plus 4 minus 4ky. There you go. I got 2 versions of OC. All right, but I'm not done yet. Oh, by the way, we can use this shortcut method for the second one as well. So for example, this is k. This is 1 minus k because the total is 1. So you notice that if I want to go from O to C, right? I take this ratio, I times with 4. So it's 4, I times with 4y. Yeah? So we can say 1 minus k times 4y, and then k multiplied by 3x. OA is 3x. K times 3x. Now, this total length is 1, right? Now, if you expand this, you get 4 minus 4ky, and then this is 3kx. Now, notice is exactly the same as this. Yeah, so much shorter. Yeah, so much easier, right? Okay, right. Now, I want to find h and k. There are 2 versions that I have. 2 versions. The first version is this and this. I'm comparing my 2 versions of OC. So first we compare your x. 5 over 3h is now 3k, right? 3k. Maybe I make k as a subject. Up to you. You can make k or h. I got 5 over 9. First equation. Then I compare my y value. My y would be this one. I'll compare this and this, right? My y is 8 over 3h, and it's now 5 minus 4k. Okay, before I sub in, I think I can divide. Let's divide by 4. Number a bit big. When you divide by 4, I got 2 over 3h, 1 minus k. This is my second equation. By the way, I missed a h here. This one is h. 5 over 9h. So let's sub equation 1 inside equation 2. The moment sub in, you don't write k, you write 5 over 9h. Yeah, I don't like fractions, so I multiply by 9 to get rid of this fraction. 2 over 3 times 9 is 6h. This is 1 minus 1 times 9, it gives us 9. This one is 5h. Bring over 11, h is 9. H is 9 over 11. Then I need to find k. I sub inside equation 1. K is 5 over 9, 9 over 11. My k is 5 over 11. Okay, 5 over 11. All right, so I've got part A, I got part B, my part C. It is given that the magnitude of x is 5 units and the area of your triangle is 90. Yeah, okay, magnitude of x is 5 units, area of triangle is 90. Okay, so now let's just drop this off. Okay, triangle OPA. OPA is a small triangle. It's this triangle here, right? Now, your base is 3x, your height is 4y, and you're finding perpendicular distance from P to OQ. P to OQ, that means we are talking about this length. We're finding this height. We know magnitude x is 5, so 3x will be 15, right? So 3x is now 3 times 5. This is 15. Very simple. Let's just use half times base. Your base is 15. Your height is your perpendicular distance, or we can say OP. The result must equal to 90. So to find your h, we take 90 times 2, divide 15. 90 times 2, divide 15. Answer is 12. So the perpendicular distance from P to OQ is just 12. You can write 12 units. Okay. Okay, question number 9. This is from 4 chapter 6 linear law. So we're given a table of values that shows variable x and y from obtained from experiment. They're related by this equation, y plus b x power 2q. Okay, so we're supposed to plot log 10y versus log 10x. Okay, I'm going to draw my table maybe over here, lgx, lgy. Okay, I have 6 values, 1, 2, 3, 4, 5, 6 values here. So for your LGX, I have to just log 1 by 1, log 1.5. I got, okay, to make your life easier, we'll change everything to 2 decimal point, fix the decimal point 2, all right, 0.18. Okay, that'll be easier. Next one, log 2. Log 2 is 0.30. All right, 2 decimal point we do, we don't need so many. Log 2.5, I got 0.40. Okay, log 3.5, I will get 0.54. Log 4.5 is 0.65. Log 6 is 0.78. Okay, next log 9.5, I got 0.98. Okay, log 27.5, I got 1.44. Log 30.2, 1.48. Okay, log 79.4 is 1.90. Next, log 138.1, very tedious work, 2.14. Lastly, log 288.4. Yep, I got 2.46. Okay, so I've got my table values done. Now, next, they say, plot log y versus log x using a scale of 2 cm to 0.1 and 2 cm to 0.2. Okay, so now here's the problem. You notice that your largest value is 2.46. If you take 2.46, okay, 2.46, I better change back this, right? 2.46, right? If you divide by 2, you will get 12 point, divide by, in this case, 0.2 on the horizontal axis. You will get 12.3. That means I need 12.3 boxes. But a standard graph paper given SPM usually is 11 by 8, 11 vertical, horizontal 8. Or if you buy those graph paper, it's 12 by 10. Yeah, so you won't be able to fit everything inside. So that's a problem. All right. So to avoid that, the one thing, your y-axis, you don't have to start from from 0. Your x-axis must always start from 0 because you want to find the x-intercept. Your y-intercept, your y-axis actually not necessary to start from 0. So for this question, right, because I want to follow the scale here, I cannot start from my y-axis from 0. Yeah, but I can still find my intercept. Yeah, it's not a problem. I can still find my x-intercept. Yeah, I can still find my y-intercept. This is not a problem. Just that it will be my y-axis. I will not start from 0. Okay. All right. So let's draw this. Okay, move this down a little bit. Move this down a little bit. Okay. All right. So this is 0. This is 0 0.1, 0.2, 0.3. Horizontal is this 0.4, 0.5, 0.6, 0.7, 0.8. I think enough. We don't need more than that because the largest x value is 0.78. Yeah. So this is LGX. Okay. For your y-axis, this is 0.2. Okay. I can't start from 0.2. Okay. My largest is 2.4. So the multiple of 0.2 will be 2.6. So I start from here, 2.6, 2.4. I work backwards. This will be 2.2, 2.0, 1.8, 1.6, 1.4, 1.2, 1.0, 0.8, 0.6. And now notice I start from 0.4 instead. Yeah. Normally in the recent SPM, right, ever since KSSM, ever since 2003, the slightly newer format, yeah, all the graph always start from 0. Yeah. But for this particular question, like I said, you can't start from 0 unless you change the scale, right? Or you use a bigger, longer graph paper. Yeah. So since I'm using this is a 12 by this is actually 11 by 8. Standard graph paper in SPM most of the time is 11 by 8. Yeah, so I have to use maximum 2.6, my minimum 0.4. Okay, now let's plot the points. 0.18, 0.98. Okay, this one I need to zoom in, very small, can't see. 0.18, 0.98. So now the smallest box is 0.2. 98 should be here. 1898, put across. 0.3, 1.44. 0.3, 1.44. Over here. Next one, 0.4, 1.48. 0.4, 1.48. 0.54, 1.90. All right. Next one, 0.65, 2.14. 0.65, 2.14. Next one, 0.78, 2.46. Right? 2.46 a bit higher up. 0.78, 2.46. Okay, I can see, yeah, almost all the points are on the same line except for one point. But sometimes you got to read the whole question. They say one of the value of y has been wrongly recorded. So we know one point is off, and it's quite obvious is the point where x is 0.3. Yeah, when the LGX is 0.3. Yeah, so we know this point is off. So just draw a line that passes through everyone else. Okay, it looks like it goes down to 0. Okay, it's not on all the lines. Yeah, you notice that this point is off. There's one point above, one point below. Obviously the point with 0.3 is the one wrongly recorded. Yeah, I think everything else is okay, quite balanced. All right, now when it comes to plotting the graph, two things very important from the graph that we need to find is your gradient and your y-intercept. Okay, so let's go and find our gradient y-intercept. Okay, my gradient from here, first of all, we need to find pick 2 points. Now, I always like to use my y-intercept itself. My y-intercept here, it looks like 0.54. This coordinate is 0, 0.54. Then we pick 5 boxes horizontally is over here. This is 0.5, 1.76. Yeah, 0.5, 1.76. Okay, I'm going to calculate my gradient from here. All right. My gradient will be 1.76 minus 0.54. Okay, 0.54 divide 0.5 minus 0. Okay, 1.76 minus 0.54 divided by 0.5. Okay, guys, my answer is 2.44. Yeah, my gradient is 2.44. You might get a slightly different answer. That's fine. 2.44. My y-intercept is 0.54. Okay. Okay, let me just go back to here. All right. Okay, I think I will show my working over here. You're supposed to find the value of P and Q. This is where we have to introduce logarithm on my original function. Guys, my original function is this. Okay, I will introduce logarithm on the left, on the right, bx power 2q. Now I'm going to break it up. LGY is now LGB in logarithm times, when you break it up, is a plus x power 2q. That 2q I will bring in front. All right, so this is LGY equals 2q LGX plus LGB. So this is my big Y, this is my gradient, this is my X, and my C. I want to compare my gradient 2q with 2.44. Q will be 2.44 divided by 2, 1.22, right? This is when you compare your gradient. For your y-intercept, I have LGP, right? LGP I got from here. From my graph, my y-intercept is 0.54. So we say LGP 0.54. My P will be, use your calculator, shift log 0.54. Basically, we call it anti-log, 10 power 0.54. I got 3.467. 3.467. So I got the value of P and the value of Q. Now, also I need to find the value of Y when X is 3.2. Okay, so this is B Roman 1, B Roman 2. When X is 3.2, my LGX or LG 3.2, I'll use your calculator. LG 3.2, it gives us 0.5. I can't read 505. I just read 51, 0.51. Okay. 0.51. Oh, I have to zoom in here. 51 is this point here, this line here. Move across. It looks like 1.8, right? Or 1.78. Around 1.78, 1.78. Yeah, 1.78. Okay, so when your Y, when this is 1.78, LGY is 1.78. To find your Y, we shift log again, shift log, or 10 power, 1.78, 1.78. My answer is 60.26. Yeah, Y is 60.26. Okay, next, the wrongly recorded value. They say use the graph to find the Y, the correct value of Y. Yeah. We know the incorrect value is this. This is your incorrect value. The correct value must happen when LGX is 0.3. So we read from 0.3, it looks like it looks like here. See? When X is 3. Okay, sorry, I think, yeah, it's around here. If it looks like 1.28. Yeah, 1.28, not 1.3. So we say LGY is 1.28. Your Y will be, calculator, shift log 1.28. I got 19.05. Yeah, your Y value is 19.05. There you go. right? That's your answer. Okay. Okay, question number 10. This is a question from integration from 5 chapter 3. So diagram shows a curve, graph of a curve with this equation y equals 6x minus 3x squared. Straight line PQ is a tangent and to the curve and parallel to x-axis. Okay, find the equation of PQ. Okay, so here actually we can use quadratic equation method or you can use differentiation, but most of the time we just use differentiation. Differentiation is easier. I mean, I think if you've been usually they combine differentiation and integration. We just differentiate. We know at the turning point, in this case, the maximum point, when you differentiate, you get 6 minus 6x. Yeah, differentiate 6x, you get 6. Differentiate 3x squared, the 2 goes down. 2 times 3 is 6. Reduce the power by 1, 6x. Now we know at the turning point, your dy dx is 0. We bring this over, 6x is now 6. X is now 1. Okay, so I know this x value is 1. Okay, I need to find my y value because the y value is representing the equation of PQ. So let's put your 1 inside. 6 minus 3. I put 1 inside directly. Is now 3. Yeah? So equation of straight line PQ is just y equals 3. Okay, next. How do you find area bounded by the curve and the x-axis? Okay, area bounded by the curve and x-axis. This is your curve. Okay, maybe I just highlight the curve. The curve is here. This is your x-axis. So the area bounded will be here. Okay, sorry. The area bounded will be here, right? So I need to find this area. Well, we can use area of integration. So we integrate from 0 to this point. Well, this one you have to use, you need to find the x-intercept. Okay, before I do that, I know at x-axis, my y is 0. So let's take 6x minus 3x squared. Let it be 0. Take out 3. Take out x. 2 minus x. So your x is either 0 or 2. So now we know this is obviously 2. This is 0, right? So we know we have to integrate the function from 0 to 2. So we write here area of integration as integration 0 to 2, 6x minus 3x squared dx. Okay, when I integrate 6x, we increase the power by 1. 2. 6 divided by 2, I write 3. Yeah? So it's actually like this, 6x squared over 2. I cancel them, I get 3x squared. As I integrate the second one, I get x power 3 divided by 3. So this is actually 3 over 3. You're left with x power 3. Okay, my lower limit is 0, upper limit is 2. Let us put 2 inside. 2 squared is 4. So this is 4. 2 cubed is 8, right? And if you put 0 inside, the whole thing is 0. Answer is 12 minus 8, 4 units. Okay, but if you don't want to use, I mean, you can use a calculator to validate your answer. I hope you know this. For this calculator, you put integrate 6 alpha x is the close bracket. Then you minus 3 alpha x squared. My lower limit is 0. Upper limit is 2. There you go. My answer is 4. Yeah, so you use this to validate your answer. Okay, next one. C. Find the volume of solid generated when the shaded region is rotated 360 about the x-axis. Okay, I'm going to rub this off. Okay, here's a shaded region. We know this is 1. When you rotate 360 about the x-axis, so let me just draw. Imagine you have a mirror image here. Let me just extend here. It looks like this, not 100%. Now let's draw a curve like this. A curve like this. Okay, now I know it's a bit ugly. So what we have here is a cylinder. This is a cylinder here, right? Then we subtract this funny looking shape like that to get the volume in between, you are actually getting a hollow shape like this, like a cup if you like, where it has solid here, but this is empty, hollow, right? So we know that this is 4. Okay, this is 1. So it's like a cylinder here with a radius of 4 and a height of 1. Okay. Sorry, it's not 4, it's 3. 3, 3, 3. Because your y is 3. Yeah. So this is 3. And then you need to subtract this integration. And when you integrate respect to y, respect to x, volume of solid generated is pi y square dx. That's your volume, right? A to b. Okay, so let me just take volume of cylinder as pi. Remember, volume of cylinder is this cylinder here is pi r square h. Where your radius is 3, height is 1. Okay, the height is the thickness here. This one from measure from here to here, which is 1. Then you minus integration. Lower limit is 0, upper limit is 1. Pi, what's your y? Your y is 6x minus 3x squared. You got to square it, dx, because the formula is y squared dx. Now, the problem is inside your bracket here, you already have a square. If you want to use the composite function method, ax plus b power n, where we copy the bracket, we increase the power by 1, you divide by the increased power, and you differentiate inside, right? Now, we use this when inside the bracket is linear. If it's non-linear, we can't do that, right? So we have no choice but to expand this bracket. So the first part is very simple. 3 squared, we know this is 9. So I'm going to write 9 here. 9 pi. This one, you take out the pi, 0 to 1. 6x, if you square it, is 36x squared. 2 times 6, 2ab, yes, 2ab, yeah? I need to expand like this. I hope you know this is a plus b squared, which is a squared, 2ab, b squared. My a is 6x. I square it, I got 36. Yeah. My 2ab is 2 times 6x times minus 3x. So 2 times 6 is 12. 12 times minus 3 is negative 36. Negative 36x power 3. And then 3 squared is 9. X squared power 2 is x power 4. All right. So I've got this already. Next, I'm going to simplify this further. This 9 pi. When I integrate this, I get x power 3. 36 divided by 3. You got to divide by 3. 36 divided by 3 is 12. Right? Let me write nicely. 12x cubed. This 36x power 4 divided by 4. It gives us 9x power 4. And this is 9x power 5 over 5. Lower limit is 0. Upper limit is 1. Okay, so let's just count. This is 9 pi minus pi. Put 1 inside, I get 12. Put 1 inside. This is 9 over 5. Then you minus 0. Okay. 5 a bit ugly, sorry. Still ugly. Okay, now this will actually give us 9 pi. Okay, 12 minus 3, minus 9 is 3. 9 over 5 is actually 1.8 or 1.4. So there's a 1, there's a 3, so it's 4. 4 over 5. So when you subtract, you're left with 4, 1 over 5 pi unit cube. And again, we can use a calculator to double check. I do not know whether my integration is correct. So we integrate here, just drop the pi, open bracket, 6 alpha x minus 3 alpha x squared, close bracket, square it further, lower limit 0, upper limit 1. There you go. I got 4, 4, 5. Yeah, so this is, I know this is correct. Okay, so I just have to subtract to get 4, 1 over 5. All right. Okay, question number 11 is from 5 chapter 1 circular measure. So here we have a diagram that shows sector of a circle. This is actually an old past year question, 1990 something, right? I think, yeah, similar to that. Okay, so with the angle here, the circle center M And this major arc here is 3.6 radian. All right. Okay, so you're supposed to find the radius. Okay. All right, the radius of the sector of the circle MJKL. Okay, we know that to find the radius, we know this is 5 cm. This is another sector, 5 cm. So we can find JM. To find JM, right, you can use the slow way or the fast way. Now, the fast way is the formula for chord. Yeah, I always teach my student to find chord is 2r sine theta over 2. My radius is 5. My theta is 1. So it's 1 over 2. Or we can say 0.5. This is in radian, sine 0.5 radian. So make sure you change your calculator to radian mode. All right, shift mode, number 4 for radian. So 2 times 5 is 10, sine 0.5. Yeah, there you go. 4.794. Yeah, 4.794. Always give your answer correct to 4 significant figure. Now, some people say, what if I cannot remember the formula for chord 2r sine theta 2? Well, you can divide this evenly at the center, right? Maybe I redraw this for you. When you divide evenly at the center, this is J. This one, maybe I call it T, JT. And this is 5 cm. If this is 1 radian, half of it is 0.5 radian, right? So we use sine. Sine 0.5 radian is now JT over 5. JT divided by 5. So your JT is 5 sine 0.5. All right. Now, but I'm finding JM. JM is the radius. Is 2 times of 5 sine 0.5. Now you notice it's exactly the same as the one above here, right? Which also gives us 4.794, right? So it's up to you. If you can remember this formula, use it because it's faster. Chord is 2r sine theta 2. If you can't, then you just do the slow way to derive it. Now, I know some people use cosine rule. Yeah, but cosine rule is a bit harder for me. Although it's still applicable, yeah. Chord formula is faster than cosine rule. Okay, second one, perimeter of the shaded region. Okay, my shaded region consists of this arc JKL plus 2 smaller arc JM and ML. For JKL, I already know the angle 3.6. For JM, I also know the angle and the radius, right? So I think we can just add them up. Your perimeter consists of arc JKL plus arc JM. You can say JM times 2, 2 times of JM, because JM and ML are the same. So JKL is R theta, which is 4.794, theta 3.6. This is 2 times, your R is 5, theta is 1. So use your calculator, 4.794 times 3.6 plus 10. 2 times 5 is 10. Answer 27.26. Yeah. Again, 4 significant figure will do. Okay, next one. Find the area of sector PJM. Okay, PJM is a small sector here, this sector here. All right. So very simple. Your area is half r squared theta. My r is 5. I square it, theta is 1. So it's 25 divided by 2, 12.5. Okay. And part D, area shaded region. Well, your shaded region, as you can see, it consists of this sector here, but you're going to minus this segment. Now, this segment actually consists of sector minus triangle, right? It's up to you. Some people want to do 1 by 1. They find area of segment, then they times 2, then they take the whole thing minus segment. Okay, you can do one shot. Okay, up to you. So let me see if I can do one shot. The big sector, the radius is 4.794. Your theta is 3.6. You must minus 2 times area of segment. Okay, for this segment, right? I always teach my student how to use this half r squared theta minus sine theta, right? It's a faster way of doing. But however, since I already know this area, I already know area of sector earlier, so I just use the result. I don't want to use half r squared theta minus sin theta. Although you can just sub inside. So area sector we know is 12.5, this one. Now this is a triangle, and I like to use half AB sine C. When you use half r squared theta minus sin theta, this is actually coming from half AB sine C, r squared sine theta, where your radius are the same. Your AB are the same, so we use half r5 sine theta. Yeah, remember formula from solution triangle, half AB sine C. In this case, your AB are both the same, 5 and 5. So I write 5 squared. Theta is now 1 radian. So I do one shot. Okay, so remember calculator must be in radian mode. So let's do one shot. Half r squared is 4.794. I square it. My theta is 3.6 minus 2 times of I put a bracket here, 12.5 minus half. Your radius is 5 sine 1 radian. Okay, right. So this is 37.41. Yeah, 37.41. Now you might get 4041, depending whether you do 1 by 1 or one shot. Yeah, if you do 1 by 1 shot, sometimes there's a slight difference in answer. Here I got 37.41. Okay, let's move on to section C question. This is question number 12, solution of triangle. So here we have a regular polygon. In fact, it's a pentagon, A, B, C, F, G, H with a triangle ADG. So given that AB is 8 and the ratio ACCD is 1 to 1, ACCD is 1 to 1. So this is 8. So since it's a regular polygon, they're all 8, and these two are equal length, ACCD. So you're supposed to find the length of AC. Now, if it's a regular polygon, you've learned this in Form 3 that sum of interior angle is n minus 2 times 180, right? If it's a regular polygon, you divide by n to find specifically the interior angle. So if you have a pentagon, so your interior angle, let's say x is now 5 minus 2 times 180 divide by 5, 3 times 180, 540, 540 divided by 5, 108. Yeah, this is 108. Okay, so if I know this angle ABC is 108, we say that AC square is 8 square plus 8 square minus 288 cos 108. Okay, use a calculator. 8 square. You can just times 2. Yeah, times 2. Then because there are 2 8 square minus 2 8 square. Okay, 2 times 8 square times cos 108. Okay, remember to change your calculator to degree mode. This is in degree. This chapter all in degree. So let me move it here. Whatever I get, square root answer 12.94. Yeah. AC is therefore 12.94. So if this is 12.94, this length is also 12.94. Okay, I got the length of AC done. Next, part B. A triangle A prime BC is constructed such that B prime C equals to BC and B prime lies on the elongated straight line AB. So elongated straight line AB means extend the line. All right. C prime lies on B prime lies on here, and it is given that BC equals to BC prime. That means C prime, B prime should be over here. Let me just extend like this. Okay, it's over here. So rub this off. These two must be equal length. Yeah, because it is given B prime C equals to BC, and B prime lies on the elongated line of BC of AB. So you're supposed to find the length of BD prime. B prime D. B prime D is over here. Right. Okay. So number one, if you want to find this length, right, I think we need to find out what is this angle here. If this is 108, this should be 72. Since the isosceles this also 72, correct? And this angle BCB prime should be 36. Okay, by the way, how do I get 36 out? You want I can show you the working. We say that CBB prime is 180 minus 108, which is 72, right? And your angle BCB prime is 180 minus 72 times 2, which is 36. Yeah. So if I know this is 36, and in fact, if these two are equal length, this is 1, this is 8, this is also 8. That means this angle and this angle must be the same. That means my angle BCA is now 180 minus 108 divided by 2, which is 72 divided by 2. It is also 36. Okay, so this is also 36, right? So how about angle B prime CD? BCD is this angle over here, right? Okay, sorry, highlighted this way. So it's now 180 minus double 36, okay, which is also 72. Yeah, sorry, not 72. 180 minus 72, 108. Yeah, so this angle is 108. And therefore, I can now find B prime D. Yeah? You're finding the length of B prime D. We square it. Is now 8 square, 12.94 square, minus 2, 8, 12.94. I'm using cosine rule here. Cos angle 108. Okay, now let's count. 8 square plus 12.94 square minus 2 times 8 times 12.94 times cos 108. Okay, whatever I get, square root, answer equals 17.19. Yeah, 17.19 to get your B prime D. Okay, it's very long because of all the angle, but the calculation part is kind of short. Just 2 lines. Cosine rule to the answer. Okay, next one, find area of shaded region. Okay, to find area of shaded region, I think the first thing is we need to find the length of GC. Let me write this off. I need to find length of GC. All right. But you can see from here, because these two are it's supposed to be equal length, right? Yeah. If this is 12.94, this side also 12.94. How do I know? Because if this is 36, right? This should be 72. Now, you want to focus on this triangle. Look at this triangle here, right? They're all identical. This is 108. This should be 36. This should be 36. So that means that this angle over here is also 72. So they are isosceles, right? So if this is 12.94, this is also 12.94. And we know this is 36. We know this angle just now. This is 108. We have almost everything. This one is 72, 72, right? This angle should be 36. Yeah. Though we can just validate if you take 180, 72 times 2, right? 144, 180 minus, you get 36. Okay, so what I am lack of is this angle here, right? Because I want to find area of this triangle. I already know this is 12.94, 12.94. Well, there are 336 here and 108. So maybe I write down angle of GCD is 360 minus 108. 36 times 3 is also 108. So it's double 108. Yeah. 360 minus 108 times 2, it gives us 144. So this angle is now 144. Okay. So 144. All right. I want to find area of this triangle. Very simple. I seriously think this question, you only use 2 cosine rule and 1 area triangle. That's it, right? So the rest are just testing your idea of polygon, a regular polygon. Half r squared, half AB sine C. Yeah, remember area triangle, half AB sine C. Your A and B are both the same, 12.94. So you can say 12.94 squared. Sine C, C is 144. So we take half times 12.94, you square it, sine 144. Guys, my answer is 49.21. 49.21. Okay, that's all. Yeah, we just use sine rule, two cosine rule, and one formula for half AB sine C area triangle. Question number 13. So here we have a table that shows the price indices and the quantities needed for rice, coconut milk, fish, and spices to make nasi dagang. So we are supposed to calculate the price for 1 kg of coconut milk over here. All right, in 2018, if the price in 2019 is 7 ringgit per kg. Okay, so 2018-19. So we have to use this 96. Yeah. The price in the year 2000, we can say that the index here is 96. Remember, index for 2018 to 19, 18 is the base, 19 is the current, is price in year 2019 divided by the price in year 2018 times 100. So the price index here is 96. Price in 2019 is 7 ringgit 50 cent. We're finding the price in the year 2018. So just use your calculator. Let us take 960, 750 multiplied by 100 divided by 96. I got 7 ringgit and 81 cent. RM 7 ringgit 81 cent. Okay, second one, the price index for rice in the year 2020 based on year 2018. Now, if you look at rice, right, this is 2018 to 19. This is 19 to 20. So normally we use this what we call a simplified chain rule. There are 3 years involved, 2018, 2019, 2020. From 18 to 19, the price has gone up, or actually gone down actually. The index is 80, so drop by 20%. Remember, if your index is less than 100, it's reducing, more than 100 is increasing. 2019 to 2020 is 120, increased by 20%. So we want to find the overall increase from 2018 to 2020. So very simple, we write index here 18 as the base, current is 20. Just so you know, sometimes some books or some teachers will write like this, 20/18. It's the same thing. This notation is not important. You don't write, it's fine. Yeah, it's just for our own reference. All right. Some people write 20 based on 18 this way. Some people write 20 based on 18 this way. Yeah? If you write in this manner, 18 is your base, 20 is your current. So we take these two consecutive indices, we multiply together, divide by 100. In this case, you will get 96. 80 times 120 divided by 100. There you go, 96. Okay, next. The composite index for the cost of nasi dagang in 2020 based on 2019 is 110. Find a value of x. Okay, 2020 based on 19 means we have to use this list here. Okay. But by the way, we need to identify what's the weightage. The weightage will be based on the quantity here. Can you see any additional information given usually represent the weightage? Now notice all these figures are divisible by 250. 1000 divided by 250 is 4. 750 divided by 250 is 3. This one is 4 again. 250 divided by 250 is 1. All right. So composite index, the composite index, this is for 2019 to 20. We know the composite index is 110. That means overall, the cost has gone up by 10%. We take the individual index, multiply weightage at 120, multiply by 4. 115, you multiply by 3, yeah, multiply with the weightage here. Then x multiplied by 4, I write 4x. And then 104 multiplied by 1, yeah, you can just write 104. Your total weightage is 4 plus 3 plus 4 plus 1, and this gives us 110, right? Okay, now the next thing is, let's calculate this. We know that 120 times 4 is 480. Maybe I just type it up for you. This one 120 times 4, 115 times 3, and then you plus with 104. 104 times 1 is just 104, 929. So we say 4x plus 929. And you notice the one below here is 4 plus 3 plus 4 plus 1, which is 12. 12 times 110 is 1320. 12 times 11110 is 1320. So to find x, your 1320, you must minus 929. 929, you get 391, and then you divide by 4. As you divide by 4, you get 97.75. Yeah, my x value is 97.75. Okay, next, the cost of nasi dagang per pack in year 2019 is 5 ringgit. Calculate the selling price in 2020 if the profit is 50% of the selling price. Okay, so this is 2019. We want to find 2020. All right, so we know the overall cost has gone up actually by 10%. Yeah, your composite index represent the overall cost. So we know the overall cost has gone up by 10%. So we can say index basically is based on this. So I don't rewrite this. In 2019, the cost is 5 ringgit. The cost is P 2020. Cost in 2019 is 5 ringgit. You multiply by 100, this is 110. That means that your cost has gone up by 10%. Okay, so we can say 110, right? When you move it over here, divide by 100 times 5 ringgit is going to be 550. Yeah, 550. Increase by 10% is 550. Okay, but this is just a cost. This is not the selling price. Okay, 550. They say that profit is 50%. So if your profit is 50%, you have to mark up by 50% and sell at 50% higher than this. So your selling price in this case will be 100 plus 50 is 150 over 100 times 5 ringgit and 50 cents. Okay, so let's take 550 times 1.5. You can write 150 over 100, which is basically 1.5. So the selling price should be 8 ringgit and 25 cents. Right. Question number 14, this is kinematics of linear motion from 5 chapter 8. So here we have a part of a velocity time graph, v equals 6t minus t squared. So you're finding the value of t if the acceleration is 0. Now remember, acceleration time graph, right? Velocity time graph is such that acceleration is your gradient. Your gradient is 0 here. Or you can actually just differentiate. Remember, when you differentiate velocity, you get acceleration. So differentiate 6t, you get 6. Differentiate t squared, you get 2t. You let your acceleration be 0. You solve for t. So 6t minus 2t is now 6. t is just 3. This is 3. Okay, so once you got t equals to 3, well, I've done part A already. Part B, find the range of values of t when the particle undergoes deceleration. Okay, deceleration means when your acceleration is less than 0. So I would bring this over. 2t is now greater than 6. t is greater than 3. Yeah. Okay, so that's it. Very short and simple. All right. Next, find the area shaded region and state what it represents. Yeah. What is represented by the area shaded region. Okay. Well, the area shaded region here, let me just write integration 0 to 4. This is 6t minus t squared. Okay, so when you integrate 6t, we copy t, increase the power by 1, 2. 6 divided by 2 is 3. I copy t, increase the power by 1, 3 divided by 3, 0 to 4. Now let's put 4 inside. 4 squared is 16, right? So I sub inside. 4 cubed is 64. Minus, put 0 inside, the whole thing becomes 0. So basically, this is 48 minus 64 over 3. Yeah? 48, 3 times 16 is 48. 64 over 3. I got 80 over 3. Yeah? Or 26 2 over 3. You can write 80 over 3 or 26 2 over 3. Yeah. And what does this represent? Remember, area under the graph for velocity time graph represent the total distance travel. So we call, what's the area? That is distance travel It's a particle, right? You can say particle. Yeah, it's a particle. Travel by the particle in the first 4 seconds. Yeah, because it's up to 4. Okay. Now, lastly, the average speed for the first 4 seconds. Very simple. Average speed is total distance divided by total time. So my average speed, my total distance is 26 over 3, or you can think 80 over 3. Your total time, you divide by 4. So it's 20 over 3, right? 80 divided by 4 is 20. Yeah? 20 over 3 is just 6.2 over 3 meter per second. Yeah, this question is quite simple for normal kinematics type of question. All right. Okay, last question, question number 15. All right, so here we're supposed to use this graph paper and sketch a graph. Let me adjust this, make it a bit lower. You're supposed to, this is a linear programming question. All right, let me move this down a little bit so I can see the whole question. Okay. All right, so here we have a boat operator, yeah, a tourist boat operation in Langkawi provide X trip to Pulau Tuba and Y trip to Pulau Besar. So the service provided is based on the following constraint. Number one, the total number of trip not more than 16. Okay, we're supposed to write 3 inequality. So I'm going to write the inequality straight away. Yeah? So Pulau Tuba is X, Pulau Besar is Y per day. Yeah? So the total number of trips provided not more than 16 per day. So I'm supposed to write 3 inequalities. So I'm going to write here. First one, X plus Y, not more than 16 means it can be 16. So we say X plus Y less equals to 16. All right, second one. The number of trips for Pulau Tuba is X, is not more than 3 times Pulau Besar, not more than, we write less equals. So X is less equals 3y. Okay, the third inequality is this. The fare per trip for Pulau Tuba is 60 ringgit. Fare per trip for Pulau Besar is 30. The total fare collection per day is not less than 540. So we say 60 times X plus 30 times Y, not less than. Not less than means greater equals 540. So for me, I'll just divide by 30. As I divide by 30, I get 2x plus y. 540 divided 30, that will be 18. 2x plus y less greater equals 18. Okay, so here, there you go. You got 3 inequality, and I've answered part A already. Okay, part B. Using the scale 2 cm per 2 trip on both axes, construct and shade a region which satisfy all the constraints above. Okay, so first I'm going to draw my horizontal axis. Okay, let me adjust it. Okay, I need to move this a bit lower. All right, it looks like that. Okay, draw a vertical axis. This is my y-axis. Oops, not too high. I think here is sufficient. I don't have to draw too high up. Yeah, I don't think we need even up to here. I think this is sufficient. Okay, now we need to draw, this is your x and y. We draw 3 straight lines. And the question say, use the scale of 2 cm. So let's do 2 cm to 2, 12, 14, 16. This is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I think 20 is enough. We don't have to draw all the way up. Okay, now the first one will be x plus y equals 16. For me, I like to use the table of values, right? To draw a straight line, we just need 2 points. So I start with x equals 0. When the x is 0, your y is 16. Then I let my y 0, my x is also 16. So 0, 16 is here, 16, 0 is over here. I just need these 2 points. Just draw a straight line that connect these 2 points here. Okay, may have to adjust a little bit, right? Okay, let me adjust. So it goes like this. So this is your x. plus y, and x plus y is equal to 16. Okay. Second equation is x equals to 3y. Or we can say y equals 1 over 3x. You can say y equals 1 over 3x also can. Let's say I start with x equals 0. Your y would be 0. But we need a second point. Maybe pick a number that we can divide. All right. Either you take y or you can take x. For example, if I take y equals to 4, x will be 12. So x is 12, y is 4. So it's this point here, and 0, 0 is this point here, Just use a straight line, pass through here. All right, second point will be here. Okay, so this will be x equals to 3, 1. All right, third will be 2x plus y equals 18. 2x plus y equals 18. Now I'd like to use, again, x equals 0. When x is 0, y is 18. When your y is 0, x is 18 divided to 9. So 0, 18, which is here, 9, 0, which is here. So again, I need a ruler, join these 2 points. Okay, we have to adjust it. All right, move this higher a bit, make sure it passes through the point. Okay, 0, 18, and 9, 0. Okay, oops. Okay, all right. So this is x plus 2y, 2x plus y equals 18. 2x plus y equals 18. Okay, we need to shade the region. Okay, now there are 3 things to consider. Number 1, the first one, x plus y must be less equal to 16. So we know it's below here. Okay, but again, a lot of people tend to assume that everything must always be inside the triangle. Not necessarily so. Sometimes it's not inside the triangle. Okay. Okay, let me keep writing this 18 first, yeah? Okay. All right. Oh, my region. So I think I better use a thinner because this is a bit too thick. All right, I'll just undo this. Yeah. Okay. This is 2x plus 3y equals 18. Once again, use a thinner one. Yeah, I just want to shade like B is below here. Can you see? Yeah, below this line, x plus y equals to 16. So that's number 1. Number 2, your x less equals to 3y. So you got to understand when you think x less equals to 3y, it's actually 3y greater equals to x. That means we're looking at y. We want it to be above. Yeah, y we look at top, bottom. X we look at left, right. So here we want above this line. Yeah, please look at y. Yeah, that means 3y greater equals to x, so it's above. Okay, so we confirm that this is true. We just need to confirm the third region. 2x plus y greater equals 18. Yes, it's above. So it's above this region. You can see that. So it's within this triangle. But please don't just straight away highlight or shade the region inside the triangle, because sometimes it may not be the case. Sometimes it can be an open-ended region. Okay. All right. My region is done. Okay. So normally we use the symbol R. Yeah, because they say shade the region R. Okay, which satisfy the constraint. Okay. Now use the graph to find the minimum number of trips to Pulau Besar. Pulau Besar is X. Pulau Besar is Y. Pulau Tuba is X. We are finding the minimum trip for Y if X trip for Pulau Tuba. Pulau Tuba is 8. What is the minimum trip for Y? So you move inside. Now, please pick the integer value. You cannot have, 2.5 trips. You can't have that. It's either 2, 3, 4, or 5. But the minimum in this case, you notice inside the region, it should be 3. You have 3 trips here. So from the graph, this is part C, Roman 1, number of trip, minimum value of Y, number of trip to Pulau Besar will be 3. Okay, next. we need to find the maximum total profit per day. If the profit per trip for Pulau Tuba is X, Pulau Tuba is 40, Pulau Besar Y is 20. So this is where we have to form our objective function. So the profit for Tuba is 40 ringgit. So if you make X trip, you make the profit is 40 times X. For Pulau Besar, the profit is 20 ringgit per trip. If you make Y trip, you get 20 times Y. So you add up, this will be your K, your objective function, which represent the daily profit. So we want to maximize the profit. Yeah, in linear programming, you always say minimize cost, maximize profit, maximize the profit. So we bring this over, this will be negative 40x plus K. 40 divide 20 is 2, so it's negative 2x, K divide by 20. Okay, so this is my objective function. So we have to draw a straight line with a negative gradient. Now, I know some teachers will ask you to put random value for K. Personally, I find a bit difficult. Sometimes your whatever random value number that you put inside K may not be inside this region, or the line may be a bit too small. I like to change to y equals mx plus c, so I can see that your objective function that we have to draw is a straight line with a negative gradient. Yeah, the gradient is -2. Normally we use a dotted line, but here we just, like, for simplicity purpose, I'll just use a straight line. Now we can draw the straight line anywhere, any size, as long as it has a negative gradient, and the gradient must be -2. So I'm going to use 10 and 5, because 10 divided by 5 is 2, or you can use 12 and 6. Okay, I think that 12 and 6 will be easier. So this is my objective function. Let me draw nicely here. This is my objective function. Yeah, it must pass through to 12 and negative 12 and 6. Yeah, we can see this line has a negative gradient. All right, so this is your objective function. Normally we use dotted line, but I think this graph here, right? I don't have the option for dotted line. Yeah, I wonder if I have. So it's okay. I'll just use a solid line. All right. So you can use dotted line if you want. Okay. Oops. Wait. Let me try again. Okay, this one. No. Okay, never mind. I'll just use this. Okay, now let's just find out. Remember, to maximize your y, your k depends on your y-intercept. Yeah, the bigger the y-intercept, the bigger your k value. In this case, your daily profit. All right. So remember, you need to draw another line that is parallel to this, right? We need another line that is parallel to this. So I just draw another line here. All right, is parallel. But this line, we need to move it up and down along this region here, such that it passes through, yeah, it must pass through at least a point in this region. See, picture this, I move it up. This point will give us the minimum y-intercept, because the bigger the y-intercept, yeah, the bigger the k, because k depends on your y-intercept. Okay, maybe I just make this line longer. It's a bit too short. Just to make it longer, easier to see. So picture this, I am going to move this up and down in the region. Okay, so when I put here, please take an integer value. Notice it passed through 8, 3. This will give us y-intercept. Not exactly minimum. I think minimum is here at 7. Okay, 7 cannot. At 8. Okay, at 7, 4. Yeah, maybe at 7, 4. It gives us a minimum y-intercept. But you want the maximum y-intercept. So I have to move it at this end. Now, this point cannot. Yeah, this point here can't, because it's still not maximum. The maximum y-intercept actually happens here when it passes through 12, 4. Can you see that? 12, 4. Okay, I may not be able to get the exact point, but I hope you understand. Is over here, 12. This point here, this coordinate at 12, 4. If you extend all the way up, it will give us the largest y-intercept. At the end of the day, you want the largest y-intercept, but you don't find a y-intercept from the graph because it's kind of hard. You got to extend all the way up and you don't have enough space, right? So we say that the k value, let me write over here, k is maximum at 12, 4. Your maximum value of k, we sub inside here, is 40 times 12, 20 times 4. 40, 12, 24. Okay, so we take 40 times 12, 20 times 4. My answer is 560. RM 560. So that will give us the maximum profit. All right. Okay, guys, I've done the whole paper, Kedah paper 2. So I hope you learned a lot in the process, right? And attempt the question yourself. All right. Hope to see you guys in the next video. Thank you for watching this.